Okay, so in this class, we'll discuss these two questions on your tuition note, 27 and 28, okay? We'll go to 27 first. This is, last class we have discussed distance, time graph for uniform speed or velocity. Today, it will be distance time graph for non-uniform, okay, non-uniform speed or velocity. So when an object or a body is moving in with non-uniform speed or velocity, what kind of a distance time graph will we get? That's what we're going to see here. So let's take an example first of a object moving with that kind of motion. Let us say this is the time in seconds today, time given in seconds, and the distance given in meter, let us say. Okay, so here at 0 seconds, the distance covered by this object is, let's say, 0 meter. And then next is here, example, after 2 seconds, it has covered 1 meter. After 4 seconds, means the time is equal gap, 2 plus 2, 4. It has covered 4 meter. After 6 seconds, it has covered 9 meter. And after 8 seconds, it has covered 16 meter. 9, 16, 4, 9, 16, yes. And then after 10 seconds, it has covered 25 meter. And one more. Let us say after 12 seconds, we timed, and finally it covered 36 meter. So from here we can clearly see that this object is covering like this. You see, huh? This is the initial point. Then it went after 2 seconds. You see here it has covered 1 meter. Then after the next 2 seconds, 2 plus 2, so that is at 4 seconds. At 4 seconds here, see, at 2 seconds, it has covered 1 meter. At 4 seconds, it has covered 4 meter, means from here to here, 4 meter. That means 4 minus 1, it has covered here 3 meter. That means in the first 2 seconds, it is covering only 1 meter, but in the next 2 seconds, it is covering 3 meter. So this object is clearly in non-uniform motion. So when it is in non-uniform speed or motion like this, what is the kind of distance time graph you will get? Yesterday for uniform speed, we got a straight line, right, inclined towards the x-axis. Today, what type will we get? Let us see. So here, okay, so here, you draw the y-axis and the x-axis. On the x-axis, we are plotting the time, isn't it? Yesterday also, so time here. Time is given in seconds today, and on the y-axis, we are plotting the distance. Today it is in meter. So here, meeting point is 0, origin, so up to 12 seconds is there. So let us try here. From here to here, let's say 2, 4, 6, 8, 10, and 12 seconds. Okay, so maybe we can go a little bit more in order to make it convenient for us to plot. Okay, so here, x-axis, or here, let's say 2, 4, 6, 8, 10, and 12. That's enough, right? The distance 36 is maximum, so let us do here 5, 10. I think that's too much. Wait, 5, 10, 15. Okay, let us go like that. You have 5, 10 meter, 15, 20, 25 meter, 35, and here 40. That's enough, right? So let us plot the ordinates 0, 0, so that the first point is this one here, 0 and 0. Then after 2 seconds, it is moving 1 meter. So 2 seconds here. As you can see, 2 seconds, 1 meter. So 2, 3, 4, 5. So here 1, 2, something like this. 1, 2, 3, 4, 5. So 1 meter means here. So as you can see here, the point here will represent here on the right side. After 2 seconds, we always write the x value first, x-axis. It is covering 1 meter. So this is the second point. Let us mark this one as maybe decide for this one here P, okay, and this one is after 2 seconds 1 meter. And the next point is 4. After 4 seconds, it is covering 4 meters. So 4 meters is somewhere here, right? See here, somewhere here. So this will be your Q, and Q is 4 seconds covering 4 meter. 4 seconds covering 4 meter. Then 6 seconds 9 meter. Then 6 seconds 9 means somewhere here. And 6 seconds, so it will be somewhere here. So this will be your, let us say, R. After 6 seconds covering 9 meter. Then 8, 16. So after 8 seconds, 16. So it will be somewhere here. So S. Then next is 10 seconds, 25. So 10 is here and 25 is here. So 10 somewhere here, 25 here. So here will be the 0.4. Yes, so T, let us say 10 seconds, 25, let us say. So this is the point T, next point here. So 1, 2, 3, 4, 5, 6, we have pointed 1, 2, 3, 4, 5, 6. Then last point 12. After 12 seconds, it is covering 36. So 36 will be somewhere here. So here, approximately it's okay. So this is the U, let us say. After 12 seconds, covering a distance of 36. Like that, we'll write the coordinates. 1, 2, 3, 4, 5, 6, 7 coordinates are there for us to plot, right? So when we plot these points on the graph of distance versus time, we see that we cannot get a straight line. So we draw the graph with our freehand, join the dots, okay? As you join the dots, you will notice that the graph is not a straight line, but it is a curve that is climbing up. Now here, P, Q, R, S, T, U. So climbing up like that. So we can write down the graph is a curve, right? Okay, point number 1. And point number 2, characteristics of a distance time graph for non-uniform speed is a curve, not a straight line, okay? Number 2 here, you will agree with this that at P, this point P here, at P, slope is, okay, the slope is lesser than at the point T. You will agree here, this slope here, the mountain slope here is just a gentle slope at P, but at T is very slopey, very steepy, right? Steepy. So what does this mean? This means, okay, speed at the point P, speed of this object at P is lesser than at T. That's the meaning. Wherever the portion of this curve, wherever its slope is lesser, that means at that moment the object is moving with slower speed. But when it begins to climb steeper like this towards STU, that means from the curve we can come to know that the object is beginning to move with a higher speed. So the speed is first gentle slope, slower, then higher slope, higher speed. So the clearly is not uniform speed, right? So for the graph tells us to decipher or interpret this way, that the points on the curve where it is lower, the speed of that object is lesser, and the points of the curve where it is higher, slopey, more slopey, that is the point where, those are the points where the same object is moving with higher speed. Okay, so that's the study of the distance time graph for non-uniform speed of velocity. Okay, and question 28. Finally, three types of distance time graph we are studying. So question 28 is the last one. This one we will discuss distance, write it down, time graph for a stationary object. Stationary, that means non-moving stationary object. So the previous two, yesterday one and today this one, our distance time graph for uniform speed is a straight line inclined towards x-axis. Distance time graph for non-uniform speed, just now we saw, is a curve, and in the portion of the curve where it's more slope, the higher speed, and portion of the curve where less slope, the object is moving with lower speed. Today last one, distance time graph for when the object is not moving. Then what type of a graph will we get? So let us just do that. Draw this one, and then let us say we have a stationary car. This is, let us say, representing a stationary car. Maybe you can draw it here. Okay, stationary car. That is at a distance of, let us say, 5 meters from a tree. Okay, so at a distance of 5 meters from a tree, let us say, not moving, stationary. So this is a stationary car, not moving for the first, let us say, at least 10 seconds. What type of a graph will you get if it is not moving? So just like the first two, the graph you draw same, that is x-axis and y-axis, and on the x-axis, origin here, and the x-axis, we plot the time as we did for the previous two cases. Let us say in seconds. After 1 second, let us say 2, 3, 4, and 5, like that it goes. Then this side of the graph, let us say this is here 1 meter. The distance here, this side, let us say, is given in meter. So let us say it goes 1 meter, 2 meter, 3 meter, 4, 5, 6, 7, like that it goes, let us say. Now at 0 seconds, when you first saw the car, we'll count it as 0 seconds. The car is at what gap from the tree distance? Yes, 5 meters. So the first point here will be at 0 seconds. It is at a distance of 5 meters. Okay, so 0 here. So this point will be with 0 seconds. The distance is 5 meters. So the first point is here. Sorry. At 0 seconds, at the distance of the car from the tree is 5 meters, means here 0 and 5. So this is the 0,5 first point. Second point, let us say after 1 second we will go and observe. Still it is stationary, means the gap is same, 5 meters. So after 1 second, draw like this. It is still here, see. And then after 3 seconds, or 2 seconds, you observe stationary, means still at 5 meter distance. So after 2 seconds, so here still. After 3 seconds, let us say, stationary means not moving. So the gap between the tree and the car is still 5 meter distance. So plot that one. So if you keep on plotting 6, 7, 8, 9, 10, if the object is stationary, after thousands of seconds also, the distance is 5 meters. So you'll get like that. So if you join these dots, which are here, first one, after 1 second, let us say. So this is the table, okay? The table for time distance. Time and distance. So here, you can write it down if you want. So here is the time in seconds, and this is the distance in meter. We're plotting this. So the second point is after 1 second, still 5 meters. After 2 seconds, still 5 meters. After 3 seconds, still 5 meters, like that. If you join these dots, the coordinates of the dot the coordinate dots of the stationary car, it will come a straight line parallel to the x-axis. So you can write here the distance time graph. Write down the distance time graph of a stationary object is a straight line parallel to the x-axis. In other words, the time axis, the axis representing the time, x-axis time in the distance time graph. Okay, so that is the nature of the distance time graph for a stationary object, always parallel to the x-axis or time axis. So the three types of distance time graph are: first one, for uniform motion or uniform speed velocity, is a straight line inclined towards the x-axis. That means distance inclined towards the x-axis is directly proportional. Distance is directly proportional to distance time, right? And then the next graph is distance time graph for a non-uniform motion. It's a curve and not a straight line. And in that we studied that the portions of the graph where the slope is lesser, the object is moving with lower speed, and the portions where it is slopy, high slope, that's where the object is picking up higher speed. And then for stationary objects, since it's not moving at all, it's a line parallel to the x-axis. So these are the three types of distance time graph we have learned, okay, in this class and the previous class. Okay, we'll continue the next questions in the next class. Okay.